Let's take a look at a multi-step question. So for this question, what we're going to do is we're going to look at toluene is used in a manufacturing explosive. 1.5 grams of toluene undergoes complete combustion, resulting in 1.5 liters of water, increasing from 20 degrees Celsius to 30 degrees Celsius. What is the standard enthalpy of formation for toluene? So, just like we stated before, the first thing we need is we need our balanced chemical equation. So we write our balanced chemical equation. We can record our standard enthalpies of formation right underneath our balanced chemical equation. And we would denote X because we don't know the value for toluene. We don't know our enthalpy change for this reaction either, so that gives us two unknowns. And we can write out our equation so we know what we're solving for. So right now I'm starting off with two unknowns, so we have to go and use the other information that we're given. And so the other information we're given is information around the calorimetry. And it tells me that if I have 1.5 grams of toluene, I don't know my molar enthalpy of combustion, but it also tells me that I take 1.5 kilograms of water and I heat it 10 degrees Celsius. So that allows me to get my enthalpy change, my energy change in my system. I can get my enthalpy change because I know it's equal to negative Q because it's exothermic. We know it's exothermic because the temperature goes up. Plus, molar enthalpy of combustion are always negative values. They're always exothermic. We can substitute our equation in. So now if we sub our values in, we can calculate what our energy change for my surrounding is. I know that delta H is equal to negative Q. I can substitute, so I get a molar enthalpy. So now I know for every 1 mole of toluene that undergoes combustion, it will release 3,909.5 kilojoules. So I have my toluene. I still don't know my enthalpy change because this is a molar enthalpy. We know it's a molar enthalpy because its units are kilojoules per mole. Enthalpy values are just kilojoules. So therefore I have to include this step to get into my balanced equation. Remember, my molar enthalpy allows me to go from calorimetry to a balanced chemical equation, but to get into the balanced chemical equation, I have to calculate my enthalpy change, where this coefficient, this 1, comes from my balanced equation. So now I know my enthalpy change. I only have one unknown instead of two. So now I can substitute my values in and I can solve.